Okay, so today is the day and we continue neat for 60 days, and let's open our neetcode roadmap. So we finalized with 4 modules, and today we'll start with linked list. So we have first 3 easy, then medium, and 3 hard tasks. So let's start with easy one. All right, so the first one, let's clean up this. And we see that we have to revert the linked list. So we are given a head of linked list, and we need to reverse the list and return the result array. So so the main constraints here, it's the number of nodes, so it to 5,000, and also values is from minus to plus 5,000. So let's think. So the main idea here is actually to understand how we would revert our linked list. So let's imagine we have 1, 2, 3, 4, and 5. So linked list only have the link to the next element. So here to revert linked list, we need a link to the previous element, to the current element, and let's try to first revert it by 2 pointers. So how to do this? So first, we should take the next node. So we are taking the next node and revert this one. So first node should point next to this one, and then we move this one to here, and then this one to the 2. After this, we take the 3 element, and we do the same operation. So let's actually do this logic. So we already have a link to the head. Let's have a link to the previous node. So it would be null. And we should do while head is not equal to null. But actually, let's check. So here we move, then we move this one. We take the next 4. We make 3 points to 2. Then we move. Then we take next 5. Do this change. Then we take next would be null. And yeah, so when we change next to head, it becomes null. So actually here we return a previous. So what's the logic? So the logic here is the following. So first we need to take the next node from head next. Then we need to do a head next equal to previous. And now we need to move our previous to head and head to the next node. And yeah, now it should work. Let's run. Okay, it's worked. Let's submit. And it also works. So let's check our submission. And actually we have the same logic here. I think our even logic more clear. So let's mark it as done and go to the next. Okay, so let's clean up this and check what we need. So we have 2 linked lists. We have to merge 2 linked lists into one sorted list. The list should be made by splicing together the nodes of the first 2 lists. Return the head of the merged linked list. Okay, and we have constraints that both of linked lists are sorted in non-decreasing order. So for example, we have 1, 2, and 4, and 1, 3, and 4. So we need to merge them like 1, 1, 2, 3, 4, and 4. Okay. So let's create our node. It would be head node, right? So like before implementation, let's think how we can do this. So let's have it like two linked lists, and of course we need 2 pointers here, and these 2 pointers will go until we will have all elements here. So we need a head node to the new linked list, and also we need a current position where we put in our element. So we create like new node, and we put this new node to the current. So we need list 1 and list 2. We have list 1 and list 2. Yes, we have a current node. So here it would be head. So can we create? So let's create, yeah, let's have it as null, here as null as well. And while list 1 is not equal to null and list 2 is not equal to null, we actually populate our new linked list. Here it would be head. And let's check. So if list 1 is equal to null, then what should we do? We should put into our current. So we already have current. So we need to create a new node and update new node with current next, right? So current next. So here we create new node, list node, and node, new list node, and with value from list to value, and current next, it would be new node, and then current would be equal to new node. And here, of course, we need to do list 2 equal to list 2 next. The same as we have list 2 equal to null. So list 2 equals to null. We should do the same logic. But from list 1. Okay. And else it means that we have 2 not null nodes. So here we check if list 1 value is greater than list 2 value. Then we do one thing, otherwise we do another thing. So if this equals, then we need to do we need to take list 2. So we need to do this one. And here we need to do this one. Quite a lot of code, so maybe we can later optimize it a little bit. So what does it mean? Here we can like definitely check if list 1 equal to null, we return list 2. Otherwise, do we have scene constraints? Yeah, so we can have 0 nodes. So if list 2 equal to null, we return list 1. So here we have these 2 edge cases that we can return. And of course, here in the else block, if our current Yes, I think that let's populate this new node with, we can check like if list one value. Yeah, I think like it would be like this: get head. Here we put list one and list two. So here we get head, and then head, it would be our recurrent node actually. And now we need to implement this get head with list node, get head, and also get list one and list two. And the logic, I think we can take this logic from here. Yeah. So in this case, we don't need current here. We just need to yeah, I think we can do like this. We don't need actually these methods. So we can implement this here, and then here it would be null, and here it would be head equal to new node, and here as well. So let's make this code more beautiful, and let's run. Yeah, so we have here the problem 1 1 2 3 4. But here like empty. 2 3, like we missed 1 4. List 1 not equal to null, list 2 not equal to null. We actually can simplify it. For example, we can do like this. Then we can remove this one. And remove this one as well. And then just have, yeah, let's have this one. Let's run. Okay, how we missed this thing? Let's check submissions. And so list 1 and list 2. So it means that here is as well, if n1 not equal, current next n1, and result next. Okay, so we have here dummy node. Okay, makes sense. Makes sense. Do I need this logic at the end? Do I need this logic? So here I have recursion. Here as well recursion. Also recursion. Also recursion. Okay, so here I have all recursion calls or what? Yeah. Okay, I have recursion calls, but I don't understand, like, what do I need this in my code? So for example, here, current next. So list 1. Or what? List 1. Okay, so here at the end we can have, what if we have something like this? Yeah, I think it should work. Runtime error, null pointer. Okay, let's check. Let's check this test case. Okay. Yeah, it makes sense. Let's check this. Yes, so now we run. And yeah, we see that we actually completed this. Let's check the next task. So yeah, next task is linked list cycle. So with linked list cycle, we are given a head of linked list, and we should return true or false if it has a cycle. So how it works? So we have one pointer and another pointer is going 2 times faster, and if they meet each other, then it has cycle. Otherwise, it doesn't have cycle. So we need another pointer. So it would be next, and it would be head at the beginning. And while next not equal to null, we do the following, and here we return false because it has cycle. And here if next is equal to head, so let's say head next, then we return true. And what we do here, so here is head equal to head next, and next is equal to next next if it's equal to null. If it's not equal to null, then we do next next next, otherwise null. Let's run. Let's submit. So here we also can check if head is equal to null, we return false. Okay, and we're done. Let's compare with our previous submissions. Yes, so it's actually the same as we have here. All right, so that's it. Thank you and see you tomorrow.